Today, we are going to talk about vectors and how they relate to the speed of Mecanum wheels. To begin, mathematical values can be categorized as either a scalar or vector. Vectors are geometric objects that have both magnitude and direction, while scalars are only described by their magnitude. You may ask, what is magnitude? Magnitude is the numerical representation of a value. The length of the line represents the magnitude of the vector. Thus, the longer the line segment, the greater magnitude it has. As you can see in this picture, vectors are present as line segments that also have a direction along the vertical and horizontal axis. Acceleration and velocity are some examples of vector values. We can do many different operations with vectors. One method to sum the vector is named head to tail. First is to set the scale. This demonstration will use each centimeter as 1 Newton. The vector is drawn by a marking dot followed by a line in given direction, resulting in an arrow. The line is known as a tail, while the arrow is also referred to as the head. If a vector is 5 Newton, then the line will have a length of 5 centimeter. The second vector's tail will begin at the head of the first vector. We can also name these vectors f1 and f2. When these vectors are connected, we get the resultant vector, known as f-net. Thus, when one vector's direction is along the x-axis and another is along the y-axis, the resultant vector will have a direction at a 45-degree angle from both axes. Vectors were important in constructing the robot. Vectors were important in constructing the robot because we used Mecanum wheels. These wheels are designed to have a force in both the horizontal and vertical axes while only traveling in the vertical direction. We will be putting one wheel in each corner of the chassis for a total of 4 wheels. By doing this, we have net forces along the vertical and horizontal direction, as well as rotationally. This allows us to move our robot in any direction we want. This type of wheels have a main drawback because of their rollers. They cannot go over obstacles or slopes, but rather have to be used on a flat surface. Robot design. The chassis of our robot was initially made out of wood, but will be later made with plexiglass. We have installed 4 Mecanum wheels at each corner of the robot. Each of these wheels have 45-degree rollers, which allows our robot to travel in any direction. To activate the actuator, we will have one versatile arm, using a gear which has teeth on only half and pinion mechanism. Our robot will be able to punch both mushrooms and kickplate actuator using a spring to propel the arm forward. This punching piece is connected to another gear and pinion which allows the arm to extend and contract accordingly. This puncher is mounted on a servo motor that also allows the angle of the arm to be adjusted based on the actuator we are trying to activate. The arm is connected to our chassis with a gear and motor system. This system enables our arm to raise and drop so as to activate the chain ball and the arc. Lastly, we will use our robot's body to push and hold the twister at the center of the game board.